our section today, we are going to use two different methods to solve this limit or to find the value of this limit. The first method is using L'Hopital rule. But before we go to the next one, L'Hopital rule, you have to differentiate the numerator separately and you differentiate the denominator separately. And you substitute by the value of x equal to c. If you still have undefined value, you can repeat using L'Hopital rule again and again until you have defined value. The other one, we are going to use a special limit for the function sin x over x when x tends to 0 is equal to 1. Let's go for the first method. This is our limit. How to change it into adopt it to use this special limit sin x over x when x tends to 0 equal to 1. I have a problem with 1 over x. So I change 1 over x into something else. I call it y, for example. Right? So I need to divide it by x squared to have 2 over x, which will be 2y. 1 over x squared will be y squared. And we'll go when x tends to infinity as y equal to 1 over x, y will goes to 0. Now, our limit changed into the limit when y to, sorry, by a mistake, I have done this one x, but it is y tends to 0 for sin y over 2y minus y squared. Now, this one needs a partial fraction. So, remember, you are lucky here because you have a first order factorization in the denominator. So you have it a over y plus b over the second factor 2 minus 1. And to find a and b in an easy way, just hide y and put the value y equal to 0. We will get 1 over 2, which is half. To find b, you hide 2 minus y and substitute by y equal to 2, so you have also 1 over 2 as a value of b. Now, yes, I have two limits. The first one, exactly applying sin x over x, but you have sin y over y when y to 0 is 1, so the first limit is half. The second limit, when I put y equal to 0, I have 0 over 2, which is 0, so the final result is half.